This is a revision video about how to calculate efficiency by looking at energy transfers and power usage. This comes up in Physics Paper 1 of AQA GCSE Combined Science. By the end of this video, you should know what we mean by useful energy transfers, wasted energy transfers, and dissipated energy. You should be able to use 4 different versions of the efficiency equation to calculate efficiency given data about energy or power, and you should be able to describe how to increase the efficiency of energy transfers. You know already that energy cannot be created or destroyed. In other words, it is conserved. However, we can change energy from one store to a different store, and we call this being transferred. But when energy is transferred, it doesn't always go to the store we want it to go to. And this is where we get the idea of energy transfers that are useful or wasted. Useful energy transfers are the energy transfers that we want to happen, and wasted energy transfers are everything else. We know that the total amount of energy at the end of a transfer has to be the same as at the start, so if energy is transferred into a different store than the one we wanted, then we can't make use of that energy. If you think about this light bulb for a second, it has a useful transfer, which is the transfer as radiation, as light. But if you ever put your hand on a light bulb while it's turned on, you'll find that it gets quite hot. And so that thermal transfer is a wasted transfer because some of the energy is going to be transferred in that way, and therefore we're going to get less light. Useful and wasted energy are important concepts when it comes to trying to explain efficiency, which is a measure of the proportion of the energy transferred that's being transferred usefully. If you imagine that in a lesson you use 100 joules of energy and you use 90 joules of energy for learning and 10 joules of energy for having a little chat, then you're being very efficient because most of your energy is going into something useful. Whereas if we flip it round and we say that you're only doing 20 joules of useful learning but you're using 80 joules for having a chat, that's not very efficient. We can express efficiency either as a percentage or as a decimal. Remember, there are 4 different ways that energy can be transferred, so when you're thinking about useful and wasted transfers, these are what you want to be thinking about. Energy can be transferred by heating, mechanically, in other words by forces, electrically, or as radiation, which could be light or sound. We can also talk about wasted energy in terms of the store it ends up in rather than the transfer that gets it there. We've already said that when the light bulb is working, it's warming up, and it will also be heating the atmosphere around it, creating a new thermal store. This is true of every electrical appliance, and plenty of non-electrical things to boot. When you're looking for wasted energy, a thermal store is your starting point. Even things that are meant to heat up may waste energy into a thermal store if they're heating the wrong thing. We can also describe this energy as dissipating. Dissipating means spreading out to the point that it can't be used for anything useful. It can't be used to do work. If you compare energy to currency, then dissipating is like throwing a bunch of banknotes into the air, so the wind scatters them all everywhere and you can't gather them back up again. A thermal store could be a useful thing if the thermal energy were all in one place, but when we're just talking about heating 1 million molecules of air so that the temperature of each one is raised by a fraction of a degree, that's not useful and we can't do anything with that energy. It has dissipated. To check this made sense, pause the video and identify the useful energy transfers by each of these 5 items. Remember, you only have 4 options to choose from, although there could be more than one useful energy transfer. The radio is transferring energy usefully by radiation, because sound counts as a type of radiation. The television, likewise, is also producing radiation, both light and sound. The hot water boiler is an easy one because it's transferring useful energy as heating. The car is going to be mechanical because the useful transfer is that driving force pushing the car along. And then the hairdryer is transferring energy usefully both by heating, because it's heating up the air, and also mechanically because it has a fan that's pushing the air out. And now the other side. Can you identify what the wasted energy transfers will be? The radio and the television are both electrical appliances, and therefore they are going to waste some energy by heating. The hot water boiler is also going to waste some energy by heating because it's going to end up heating things that aren't the water. But also there might be some radiation. We might have some sound being produced as the water's gurgling in the pipes, and that's wasted energy transfer too. The car, again, we've got heating, if you think about the tyres getting warm, and also some sound. And then for the hairdryer, it's mainly going to be sound. Before we look at the equation to calculate efficiency, I want to show you this Sankey diagram. Although these aren't explicitly described in the GCSE specification for AQA anymore, I think they're really helpful for understanding what's going on in terms of describing energy transfers. These arrows represent energy, and the width of each arrow represents the total amount of energy. As you can see, at the start we have 5 squares, and at the end that energy is divided up into an arrow that is 1 square wide and an arrow that is 4 squares wide. So we have conservation of energy because 1 plus 4 is 5. And we can even put some numbers on this. So let's make 1 square wide mean 1 joule, and then we start with 5 joules. So then let's say this diagram represents a light bulb that we're supplying with 5 joules of energy. And then the arrow to the right is the useful energy transfer. This is my transfer by radiation as light, and there's 1 joule. And then my wasted energy going down to the bottom into the bin is 4 squares worth of heating, so that's 4 joules. Now, if I wanted to express what proportion of the energy was being transferred usefully, I could look at this as a fraction, and I could say, well, it's 1 joule out of 5. And if I wanted to, I could simplify that fraction to a decimal and say, well, that's 0.2. Or I could put it as a percentage and say that's 20%. And this is exactly how we're going to calculate efficiency. Now, we said that there are 4 different equations for calculating efficiency, but they're all really just variations on this same idea. We're just making a fraction. We're doing how much is the useful energy transfer out of the total energy transfer. And it doesn't matter whether you use total energy input or total energy output, because conservation of energy tells us that those two things will be the same as each other. Now, just in case you weren't sure, when we write something as a fraction, what we mean is the thing on top divided by the thing on the bottom. So we're going to do useful energy transfer divided by total energy transfer. So here in this worked example, we have a light bulb that is transferring 24 joules usefully, because the light radiation is the useful transfer, out of a total of 48. So I need to do 24 divided by 48. And that gives me an answer of 0.5. Pause the video and have a go at the next 5 on your own. So in each instance, we're doing the useful transfer divided by the total transfer. So for the first 2, we follow the exact same process that I used in the worked example. 45 divided by 150 is 0.3, and 48 divided by 120 is 0.4. Now for the latter 3, we need to do an extra step because I haven't told you the total energy. So you're going to need to work it out. So 13 plus 37 is 50 in total. 13 divided by 50 is 0.26. Then 17 plus 23 is 40 in total, and 17 divided by 40 is 0.425. And then 12 plus 18 is 30, and 12 divided by 30 is 0.4. Our second variation of the efficiency equation is if we want to express our answer as a percentage rather than a decimal. So we're just going to multiply by 100 and then write a percentage sign at the end. Make sure that you're not doing this and using the percentage button on your calculator, because then you'll be doing the same thing twice. In this question, we're looking at a stove transferring a store of chemical energy as a thermal transfer. So the thermal transfer is the useful transfer. And so we start off in the same way we did before, dividing 60 by 240. But now to express it as a percentage, I need to multiply it by 100. So 60 divided by 240 would be 0.25, and that times by 100% gives me 25%. Pause the video and have a go at these 5 questions yourself. So for question 1, 480 divided by 600 would be 0.8, and 0.8 times 100% is 80%. 576 out of 1280 times by 100% is 45%. 806 divided by 1300 times by 100% is 62%. 153 divided by 450 times by 100% is 34%. And finally, 114 out of 760 is 15%. Now for each of the 2 equations we've met so far, which have involved energy, we can use the exact same equation but with power instead of energy. So everything else is exactly the same, it's just that the numbers you're given are going to be given in watts rather than in joules. So in this question, we're asked to give our answer as a percentage, and we're looking at a bulb that transfers 5 watts of power as light radiation out of a total of 80 watts that was transferred to it electrically. So we're going to do this fraction, so we do 5 divided by 80 and then multiply by 100% because we want to give our answer as a percentage, and that gives me an answer of 6.25%. Finally, if you're taking the higher tier of either GCSE Combined Science or GCSE Physics, you need to be able to discuss how we can improve the efficiency of energy transfers. And this is all to do with reducing any kind of waste transfer. So if you think about something like heating a pan of water, then the reason that we add a lid to that pan of water is to make sure that as much of the energy as possible is transferred into the thermal store of the water in the pan. We're not losing any energy because some of that water is evaporating into the atmosphere and taking some of that energy with it. We could also think about something like a hot water boiler in your house and how it might have cladding around it or insulation around it, and that again is to maintain that thermal store of the water inside the boiler rather than having energy lost by heating to the atmosphere surrounding the boiler. Thank you very much for watching, and I hope that you found that a useful introduction to efficiency and how to calculate it. If you did find it useful, then don't forget to like and subscribe for more GCSE Physics videos coming soon, and if you want me to cover some other topics, don't forget to let me know in the comments below.